Hello everyone. In this video I'm going to go over another orange example about logistic regression classification problem. Alright, we again have a model about cell phone churn. Um, we try to identify the customers who are about to churn, which is like cancel their service. Uh, and that's our variable for yes or no. And it's given in the here in the problem. I just checked this one, but it's just a similar orange style. You upload the file and then you make your selection. So let me just go over that briefly. I was working on this. Let me close that one. So you import the file, you use a cell phone churn, and then your column should be churn is your target column, and customer in the problem it says just remove that one. Number two, you just do that. Please make sure it looks like this. Customer is not in there, and churn is your target variable. And then data sampler in mine, it says 74%. So I just choose that one to be 74% of the data. And then I sample that, I run that one. And then when I look at the logistic regression, I want to tell you this. I mean, if you test these, I got the best one to be 0.40, and then that's how you choose a C. It's originally given to be, I think, 5, or it should be 5, I think, but you need to make it 0.4. In mine, it's 0.4. In yours, it might be different, and then you're using lasso. It gives you all these directions, by the way, over here. And I'll look at the AUC of that model. Once I run that one, I look at this, and then my AUC is 0.814. So I enter this value. That's how I got this one. And then I start to look at the coefficients. So for the coefficient table, you need to go over the coefficients in there, which is right here. But before that, please make sure in the logistic regression you again make this selection to be 0.4 and lasso. That way you're going to get the coefficients of the regression. And then once I look at it, it starts as here 0.498 and 0.050 and then and so on. These are the coefficients for each variable when you write down the regression equation, and you enter these over here. As you see, I mean, it's a long one, but here really how those coefficients affect the model, your decision, is just really what it says, what you see over here. So for example, if the coefficient is greater than 0, that means if the account weeks is greater than 0, that means the probability of that customer will churn increases. If it's negative, it's going to be decreasing. So that's how it affects the final outcome. And you can fill this up based on that one. Now, the last part is just from the final model. It says look at the compute the left on top 10% of test observations most likely to churn. So what does that mean? You try to figure out the number here, which is going to give you, when you use the model, it's going to give you the coefficient for the number of churners in that top 10% group, rather than a randomly selected 10% of the group. So, for example, in my model, you're going to go into the the performance curve with the test right here. But click on this one, and you can make it bigger. It might be small, but you can make it bigger. Go to 0.1 from here, and just look at the 0.1 left. Let me see. I need to go a little bit to the left. 0.1, as you can see, it's 2.218 right here. Oh, I lost it. Also, let me just show you again. 0.1. 0.1 is 2.218. So that's what I put over here. And that's going to go over here. What does it tell? It tells you that rather than choosing a randomly 10% of customers, if you use the 10% most likely to churn from the model, using the model, then you're going to be getting more than the double of the churners. That's really a good, I mean, it's a this is a good number for that. Like, for example, out of 100, if 10 of them, if you have 5, for example, churners, let's say, when you select randomly 10% of that, if you, let's say, um, let's say um, you have 100, for example, and in 100, let's say you have 20%. So if you just select randomly 10, you expect 2 of them to be churners, right? Based on that one. If it's like 20% is what you have. If you select randomly 10%, you're expecting that two of them to be churners. But if you use the model and select the top 10% based on the model, it's going to go 2.2 times that number. So it's going to be more than 4 of the churners will be in that top group. So I'm trying to explaining that, but this is really what it means, that that lift measure. So it's kind of like telling you that the model really catches like more than the double. Rather than choosing the randomly selected 10%, you can choose the model's top 10%, and that's going to give you double of the number that you're expecting from a random selection. So I hope this is clear. Please let me know if you have any questions. Thanks for watching. Bye.